When we think about fighting climate change, we usually picture these huge forests, right? But what if I told you some of our biggest, most powerful weapons are actually hiding in plain sight, right along our coasts? These places aren't just beautiful, they are carbon-sucking powerhouses. So yeah, let's dive into the pretty wild world of blue carbon.
Okay, just look at this number, over 30,000 teragrams. To give you some perspective, 1 teragram is 1 million metric tons. So yeah, that's the mind-boggling amount of organic carbon that's already stored in our planet's coastal ecosystems. It is a staggering figure, and it makes these habitats absolute climate superheroes. So what are these coastal superheroes? We call them blue carbon ecosystems, or BCEs. You know them, they're the tidal marshes, the mangrove forests, the seagrass meadows. They basically act like these giant natural sponges, soaking up carbon from the air and locking it away in their soils, sometimes for centuries. Protecting and restoring them is seriously one of the best nature-based tools we have in the climate fight. Now you're probably thinking, great, but how do we actually pay to protect all this stuff? Well, that's where carbon credits are supposed to come in. The idea is that companies, or even countries, can offset their emissions by investing money into protecting and restoring these ecosystems. It's a brilliant concept, and it could unlock billions for conservation. But, and this is a big but, it's not quite that simple. Because buried deep in the accounting rules and all the fine print, there is a massive debate raging, a carbon counting controversy that is seriously threatening to mess up this whole blue carbon market. It's a really high-stakes fight that could either supercharge conservation work or just stop it dead in its tracks. The entire carbon credit world, all of it, rests on this one single idea: additionality. It's a simple concept, but it is so important. Basically, you can't get credit for something that was going to happen anyway. For a project to count, it has to prove it's creating a new benefit for the climate that wouldn't have existed otherwise.
And that, right there, brings us to the big mystery. What happens when a restored mangrove forest traps a bunch of carbon-rich gunk that just washed in from a river upstream? Does that imported carbon count as additional, or are you just, moving carbon from point A to point B? This is the question at the very heart of the whole controversy.
And the problem is, the world's top organizations, they can't agree on an answer. You've basically got 3 main players in the game: Verra, the IPCC, and an Australian group called BlueCam. They each have their own rulebook for how to count this stuff, and, well, they all say something completely different. First up, you've got Verra. They're a huge standard setter in the voluntary carbon market. Think of them as the super cautious accountants in the room. They argue that this imported carbon might not really be additional. So just to be safe, they want projects to subtract it from their grand total. Then there's the IPCC, the UN's big climate science body. They're like the scientists trying to create one universal rule for everything. Their rules don't really talk about imported carbon directly. Instead, they just apply this flat 4% deduction for what they call refractory carbon. That's the really stable stuff that's going to stick around. But here's the catch. That rule is based on data from only one ecosystem: mangroves. It's a bit of a blunt instrument.
And finally, there's Australia's method, blue carbon. These guys are the optimists of the group. They come at it from a completely different angle. They say, hey, wait a minute. Carbon that washes off the land was probably just going to end up back in the atmosphere anyway. So if a coastal wetland traps it, that's a new climate benefit. They call it an avoided emission, and they argue it should be counted in full, no deductions. It's a bold stance.
Okay, so how much does all this accounting nonsense actually matter? Well, a lot. Take a look at these numbers from a recent study. The IPCC, you see there, they discount 4%. BlueCam, 0. But look at Verra. Their default value is almost 13%. And if you use actual data from a real-world site, it jumps to almost 25%. That is a massive difference.
And this chart just drives that point home. We're talking about the exact same restoration project. With BlueCam's rules, on the left, you get to count 100% of the carbon. Awesome. With the IPCC in the middle, it's 96%. Still pretty good. But with Verra, on the right, you might only get to count 75%. That gap can be the difference between a project being funded or not. It can make or break the whole thing. So why is this so complicated? I mean, why is it so hard for everyone to just agree on a rule for this imported carbon? To get that, we've got to dive a little deeper into the science. So it all comes down to where the carbon is from.
You've got autochthonous carbon, that's the homegrown stuff, produced right there by the plants in that ecosystem. Then you have allotoxinous carbon, which is the imported stuff. It's made somewhere else and gets washed in. A great way to think about it is like a home-cooked meal versus takeout.
But where it's from is only half the story. We also have to know how stable it is. Refractory carbon is the gold standard. It's tough, it's resistant to breaking down, and it stays locked away for more than 100 years. Labile carbon is the opposite. It's unstable and it gets released back into the atmosphere really fast. For a real climate benefit, you want that stable refractory carbon. For sure.
And here is the absolute scientific heart of the problem. That imported allochthonous carbon, it's often the more stable kind, which is great, but, and this is a big but, we don't really know what happens to it if that ecosystem gets disturbed. What if there's a pollution spill or the area gets drained for development? Does that stable carbon stay put? Or does it all get released? The science on that is still up in the air, and that's what makes this so tricky. This uncertainty, it leads to some really flawed shortcuts. Remember that default deduction value from Vera? Well, get this. It's based on data from deep sea sediments, not the coastal wetlands that the rule is being applied to. That's like using a recipe for a cake to try and grill a steak. The basic ingredients are just wrong. It's a total apples and oranges situation.
And the stakes from using these bad numbers are incredibly high. With Vera's default rules, we could be writing off a massive portion of the world's blue carbon potential. I'm talking about projects in over a quarter of the world's mangroves, 30% of its marshes, and you won't believe this, over 50% of its seagrass meadows. If those projects are told they have no additional value, they just won't get funded. Simple as that.
And here is the ultimate crazy paradox. The very ecosystems that are the best at fighting sea level rise, the ones that are amazing at trapping sediment and literally growing taller over time, those are the ones that trap the most imported carbon. So the rules as they're written now are actually punishing our most valuable, most resilient coastal habitats. It's like we're benching our star players just because they're too good at the game.
Okay, so it's a mess. How do we fix it? Well, the scientists who wrote the study we've been talking about, they've actually proposed a really clear path forward. It's a much more scientifically sound and frankly more practical approach that could unlock the true potential of blue carbon.
Their main recommendation is actually really simple and powerful. They're basically saying, look, if you can't accurately measure and justify a deduction with solid science from that specific project site, then just don't apply one. In other words, don't let a flawed guess kill a valuable climate project. It's a common sense idea that could change everything.
So here's their proposed game plan. It's a really pragmatic two-step process. Step 1, if you can, use good, rigorous, on-site science to figure out the exact amount of that stable imported carbon. But, and this is key, if that's just not feasible or affordable, then step 2, it's better to just include all of it instead of using some inaccurate default value that could tank the whole project.
At the end of the day, this whole debate really just boils down to one fundamental question. Are we going to let the perfect be the enemy of the good? These accounting rules are trying so hard to create this flawless, perfect system. But in doing so, they risk causing total paralysis. And it just leaves us all with this thought. In the race to save our planet, is imperfect, science-guided action maybe better than waiting for a perfection that might never even come? The clock is ticking, and our coastlines are waiting for an answer.